Awesome. Today we're going to be talking about Python and a little bit about interacting between Python and R. Let's talk about a real quick reminder. A lot of our old scripts at the lab are Python 2 scripts, and Python 2 is actually not supported anymore at all. So when you run Python on the BI servers, you get Python 2. When you run Python 3, all one word, you get Python 3. For new things, you should always be using Python 3. That's the end of that reminder. And there's some small differences. Overall, Python 3 is just easier to use. So the main thing I want to talk about before we get into actually trying to use a Python notebook is environments. We've got kind of this complicated ecosystem where you want to be able to write code and then give it to somebody else in an entirely other lab and have them run code. So you want to kind of encapsulate your environment, which means what version of Python you're running, and all the libraries that you're using. And those are kind of combined into what I would call an environment, right? So some of the goals are to make it maintainable. So you can send it to somebody or send it to your future self and have it actually be reusable. It's nice if it's packageable so you can easily distribute it. If you use some of these tools I'm going to show in combination with publishing on GitHub or some other open source repository, people will be able to just, in a single kind of line, they'll be able to get it from Git, and then another single line they'll be able to configure it for their own system and get all the packages that you're using at the versions you're using them and things like that. And that's what really makes the dependencies clear and easy to install. If you've used R, you're very familiar probably with install packages commands and having to build things. Python is kind of the same. Everyone has kind of different assumptions about what an environment contains, and there's a ton of different ways to do it with Python, partly because the creator of Python was kind of agnostic about how people should do this. So people came up with a bunch of different ways. And there's kind of an unclear distinction between, you've got your Python binary that actually runs Python code, and you've got all the packages that go along with it. And then you've got kind of your project environment, which contains the stuff you need to run your project, right? So here are some ways to set all that up. The easiest way is to just run Python itself, which is on almost all machines these days by default on Macs and Linux. But maybe you need a newer version that for your particular use, there's some new feature in 3.8 or whatever that you need to use. You can always just go download, and I'm going to send out the slides later. These are all links. You can always just go download a Python and install it, but it's a little bit clumsy to do. The thing for packages, the default is pip. If you run pip install, it's going to install a package. You run pip install and then a package name. It's going to install on your entire machine, or try to, which is good if it's your laptop and you're working locally and you just want, you're like, I know I want this package always available on my Python. Boom, off you go. If you're on the BI server, you're going to need to do -- user to say, put this in my home directory, because you won't have permission to install it for everybody. So that's your own account on anyone else's machine. And then venv is the new thing in Python 3. I've looked at it a bit, but it's still not useful enough to be worth a look. So don't use the built-in venv. If you need an environment, you can use virtual env. So this is kind of a long-standing standard for package isolation, where you can say, here are the packages that I need for my program to work, and create a file that stores those dependencies. And then someone else can say, hey, virtual env, make me a little box that contains all these packages. The slightly newer way that lots of people use is anaconda. And the command for it is conda, so that's why it says conda first. You can install anaconda, which if you did it before this class, that's awesome. We'll be able to do a little demo later. Anaconda kind of includes a whole bunch of libraries and stuff inside it, whereas miniconda just kind of gives you the base layer, and then you can add things onto it however you want. But conda is kind of a combination, whereas virtual env lets you list your packages and say, get these packages, it doesn't maintain your Python version. Conda maintains both. So a Conda environment is composed of both a Python version and all the packages that you've installed into that Conda environment. And once you've got Anaconda on your machine, it's very easy to make multiple environments and say, spin up one for a project and spin up another one for a different project and have them have different things installed. So usually we recommend people use Conda because it's all self-contained. There's a page in the wiki called Python, using Python in studies that I've linked here, which makes it relatively easy to link into with set study so that everybody working on the study is using the same Conda, unless you need to have multiples, and we also support that. There's a newer tool I've been experimenting with a bit called PyEnv, which is a bit less overhead than Conda. It only worries about your Python binaries. So it's doing the Python version isolation. And I haven't used this by itself. I've been using it with the different combination tools. There's one called PyEnv virtual env that will maintain your Python binaries and your virtual env packages together and kind of link them the same way Conda does. And it also knows how to deal with Conda environments. And then there's this new thing called Poetry. Nate in the chat says PyEnv virtual env on his laptop and miniconda on the server. Yeah, I've been mostly doing that, but I've started experimenting with this new thing called Poetry, which is kind of a very opinionated all-in-one tool that once you've got it set up, you kind of have a Poetry file that lists all your dependencies. And then there's one command that you run everything through, Poetry space, run whatever, and or add whatever, and it takes care of all of the things, but it does it in a way that it kind of assumes you want to do it a certain way. Most of the time that's good, and that's been actually pretty decent. There's another one called pipenv that I have not tried to use yet, but it's the same kind of thing where you are joining all this, all the problems where you want to make a single Python version work with a whole bunch of packages at specific versions and make it very easy to give to someone else and have them get the same setup. The other question that gets asked once in a while is how to link between R and Python, because R is great for stats, but maybe it's not so good for all the other glue stuff. And in fact, I find it pretty confusing to do some simpler things with, whereas Python would be easier. So there's two main ways. There's this reticulate tool linked here where you can use Python inside RStudio or R, and then it knows enough about virtual env and Conda that you can link into a Conda environment and run Python code using those libraries and pass data from R into Python. If you want to go the other way, there is a tool I have not tried yet that Nate recommended called rpy2, which lets you do stuff in Python, but then call out to R for your stats. So a lot of times that might be easier to do, say, load up a bunch of like acknowledge files with bioread in Python, and then do a little processing on them and get them ready to send to R, and then in R do your various dirty work for statistics. So, any questions about all of that nonsense? I kind of speed read my way through there. If there are any questions, raise your hands in the thing.
Oh,
all right.
Sorry, wait, Dan, wait. I'm raising my hand. I don't know how to do that. Okay, I raised my hand.
There you go.
So just kind of in the context of having dealt recently with a whole bunch of crufty old MATLAB code that ends up being pretty fussy about the environment that we run it in, that really likes MATLAB R 2017A.
Mm-hmm.
Is there, and maybe this is just a general question for the universe, is there a way in Python to kind of relatively painlessly check to make sure that the code is running in the version like that you wrote it in? You can just kind of say, okay, about this snapshot environment, and this is what it runs in, and I just want to have my code just do a quick sanity check that it's like, yeah, this is what I expect it to be.
You can check the running Python version. I wouldn't necessarily, I would check to see if it's greater than or equal to, because Python doesn't really have the backwards compatibility issues as much as MATLAB seems to, or the weirdness, I guess. But the Conda, once you have Conda set up in a study, those binaries stay in place, and you're no longer using the system Python. You're using those Conda binaries, and they don't change until you tell them to. So it's more encapsulated. Does that answer the question?
Yeah, I think so. Thanks.
As long as you stick with conda, you're going to make sure that the Python version doesn't change out from under you, basically.
Yeah. So you basically just, it's all it's all a package. You don't just have the source code. You have the source code plus the whole environment.
Yes.
So that's okay.
Yeah, and the conda gets stored in the studies like apps directory, and then engaged whenever you say set study afcron, then that conda is activated, and anybody who does like install a package, it actually goes into that conda, and then everybody using that conda will have that package. And in general, Python has been stable enough that you don't have to upgrade versions unless you want to get new base library features and stuff. I don't know. Nate, do you have any opinion on that?
No, I like upgrading Python because it usually doesn't break things.
Indeed.
Many of its libraries also are pretty good about being backwards compatible.
Yes.
I will say if you really, really, really care about environment stuff staying the same, you want to look not just at Conda, but probably something like Docker or Singularity.
Indeed.
But that is a whole nother world of things.
Yeah, and that's actually a good time to mention, if there's other things that you want discussed in these little gatherings, Singularity was one of the, Singularity and Docker were one of the options I'd put on the survey, but people did not choose it, possibly because you just don't know what that is. But that's a way to make an even more rigid box that you say, here's the software inside the box, and you freeze it for all time inside that little container.
Yeah, I mean, particularly for a study like Midas, where it's just this super longitudinal study, and we want to keep running the same code forever. That seems...
Yes, definitely a good idea. Unfortunately, you can't do the same kind of thing for stuff like CyclePy, but yeah, anyway, we can delve into that in a later thing. I've got some raised hands. Andrew.
Hey, thanks for calling on me. For reticulate, so can you use that to write, could you put Python code in the same script as an R script, or would you have to like call a Python file?
You can embed it. You can basically call out to Python and embed it. The way I've seen it done most often is in a notebook, where you're just, the way the libraries work is they make it fairly transparent, where you just say, now I'm making a block of Python code, and it has access to the same scope as R by default. So it's pretty transparent, actually, in Reticulate at least.
Cool.
I haven't tried RPy2, but that's the whole idea, is that you can prototype inside a notebook where it's both R and Py, and they're kind of interspersed as you need them. I don't know. I haven't actually done that much development like that. Has anybody done stuff with that? Want to talk about it?
I've only tested it and made sure it like worked in principle.
Yeah,
but
that's all I've done too. It seems interesting, especially because I'm not an R expert, and getting R stats access is pretty powerful. So I don't know. Let's all do a little bit. For those of you who installed Anaconda, let's go in and start it up. It's a little bit different on Windows and Macs. On a Mac, it will just go into your bash RC like on Linux, and you'll just have access to the command conda. I believe on Windows, you need to go into your start menu and find the Start Anaconda command prompt option. Either way, do that thing, start a terminal or start an Anaconda command prompt. And what we're going to do is we're going to type conda create -- name example. And hopefully you can see pretty clearly where the spaces are on the screen. And what this is going to do is it's just saying, hey, Anaconda. Oh, if you couldn't find conda, that means the Anaconda install must not have put the right stuff in your bash RC. Oh, wait, you're using Z shell. Nate, is the Anaconda installer not smart enough to put it in Z shell for Macs?
It did for me, but I'm using miniconda, and so, yeah.
That's weird.
Wait. I'll chat with Liz a little bit.
Awesome.
It also didn't work for me.
What platform are you on, Andrew?
Z shell.
Say again?
Mac Z shell.
Okay. There must be something funky on Mac. Well, if 3 people have it broken, that's extra weird. Yeah. How are you starting up terminal? You're just going to Spotlight and typing terminal?
Yeah, just the normal clicking on the dock icon.
Okay. And if you did it recently, if you installed Anaconda recently, you might need to restart. Oh, and Nate says there might be a launch a terminal thing inside the full Anaconda. That's weird because miniconda definitely puts it in the Z shell RC.
Yeah, well, I just did it today. When I had it on my computer before, it like did a lot of stuff at startup where it would like, it would like put stuff into my terminal.
Oh, weird.
But it's not doing that now.
Okay, Liz restarted. Try just closing down terminal. Like do, if you don't mind, Andrew, do Control Q or Command Q.
Or just Command N should get you a new terminal.
Yeah.
And that one should have Conda in it.
If it doesn't work, you're just gonna have to look for now, and we can get it working after this.
Typing condo. Yeah, I still don't have it, but it's fine. I'll just open up the full program.
Cool. Yay.
Oh no, I clicked the link. Okay, so once you've got your terminal, try doing conda space create space minus name space example, and this is going to make a new environment called example, which you can get rid of later if you want, but we're just going to make an example environment to mess with. And then once you do that, you can do conda env list to list the available environments. Conda is kind of sneaky smart. If you do conda env list on the BI servers and you have personal condas and study condas that you've used recently, it will actually somehow know to list them all, which is kind of weird. But on a local machine, it should just show you that you've got probably, if you just installed it, a base environment, which is the one that comes with conda, and an example one. When you want to go into a different conda environment, you say conda activate and the name of the environment. So we're going to do conda activate example, and I'm going to do this with you.
Then what? Conda.
Oops. Sorry. My keyboard shortcuts are going crazy right now.
What? Man, that thing really barfed.
Oh, now I broke my setup by uninstalling it lately. Nah, we'll go with my already running processes. I tried to uninstall right before the class and then reinstall, but I must have done it wrong.
So I got like this huge error message when I tried to do that. Yeah.
Well, apparently conda is not as reliable as we had hoped. What OS are you on?
This is on Mac OS.
Okay.
14.
We'll debug post class and just continue for those for whom it is working. After you activate, I'd like you to type. Go ahead.
Actually, Dan, how do I activate the base? Just so I can.
It should be activated by default if you type conda space activate space base. It will reactivate it. It should be activated by default though, and you should see a parentheses at the beginning of your prompt that says base. That's the default, I believe. Could be wrong. I don't have a Mac. If your conda is working, type conda install Jupyter with the weird Y spelling here, which is going to install Jupyter Notebook for you. And John, you might already have a conda or a Python environment with a Jupyter Notebook, so you can skip the previous steps. And that will run for a little while, right, to go get packages that Jupyter needs. But I want to ask a question. Does anybody who's not Nate, know the difference between saying conda install Jupyter and pip install Jupyter? Liz's question is definitely related to the question I'm asking. Anyone?
Here's like my guess based on that hint you just gave would be that like conda does it just for your environment you just made, and pip install like gives it to you as a person, or like?
Yes, pip install actually installs it for the whole machine if it can, and pip install -- user would give it to you as a person across all Python and conda environments theoretically. Conda install Jupyter will download a pre-compiled set of packages from the conda servers instead of the pip servers. In practice, it's not actually all that different, but if you're trying to make sure that your conda environment contains just the packages you want to use conda install Jupyter, because then later you can use conda commands to see what packages you have installed specifically into that conda environment. So once you've got Jupyter installed, I want you to type Jupyter space notebook. And if your web browser is set up normally, this should do some spinning and print out some stuff with some links in your terminal, and then also open a new pane in your browser. And then I don't know if everyone here is familiar with how to end tasks in a shell window, but if you're like, oops, that's not where the directory where I wanted to start up my notebook server, you can hit Control-C. So I'll show you here. If I have things running and I'm like, oh, that's not where I meant to go, it will say Control-C, shut down this notebook server. I can say yes. And actually where I want to go is make sure I'm in downloads and then run Jupyter Notebook. So if you happened to follow along and download my mess of a download folder, if you downloaded the simulator notebook from the link in the email, you should be able to open it up by clicking on it in your list, navigating to it in your Jupyter Notebook file list, and then clicking on it, and you should see something like this. If you see something like this, click yes in your Zoom window. Yay, some people are getting it. Okay, if you're not getting it, it's not the hugest deal. You can kind of check this out later or just see it as I'm doing it. So a Jupyter Notebook lets you store Markdown, R, Python, other languages that it integrates with, and then kind of package them up to send this file around. So I was able to send you this file, which contains a bunch of code, and if you scroll down, it contains some histograms and stuff. Those are cached in here in the notebook in the exact state of how I ran them. So if all I did was I said save and checkpoint, file save and checkpoint, and it made this .ipnb file, which I can then send to other people and collaborate on these interactive notebooks with them. I'm kind of running close to my 30-minute time, but I do want to show a little bit about how to use a notebook so you can get started writing Python in your notebook. The first thing I want everyone to do is go to the kernel menu and go restart and clear output. When you do this, it's going to say, well, are you sure all variables and outputs will be lost? Say yes, that's fine. So the kernel that it's talking about is in your terminal window, you've got that Jupyter Notebook command running. It's running a Python kernel with a bunch of stuff loaded that is then talking to your web browser and creating this kind of tunnel to be able to run code. Now, if I click run on a cell, there's multiple cells in a notebook. I can click run on a markdown cell and I can edit a markdown cell. Markdown is a simple way to describe text with really plain text markup like hashtag for headers and things. You can read about that online. If I have some Python selected and I click run, it will run that and then go to the next cell. So I can keep clicking run to run a cell at a time, or I can click this double arrow will restart everything and run the whole thing. For now, I'm just going to keep clicking run. The equivalent of clicking run is also shift enter on your keyboard, because you're going to be moving around a lot with the arrow keys, and you can say, oh, I want to rerun that particular thing. If you get further down in the notebook and you actually get to the section where it says fake a whole bunch of data and look at it, you will notice that it's going to sit here at the in and just say star in the left. And what that means is it's still thinking. It's still running that code. This code is a simulator that takes quite a while to run, as an example of just a long running task. Eventually it'll finish, but while it's still going, you can still queue up other things to run. And eventually it'll send all your commands once the things go through. Oh, that's my mistake. I should have told you to conda install matplotlib. I thought that was in the default conda, but maybe I'm wrong. And if you close the terminal, your notebook will die. Yes. So I just wanted to show that it's very easy to do plots with Python. This is a really simple function that just does a histogram plot. It says, hey, I'm going to make 30 bins, and I've got some data, and I want to title it something. So I can call this by saying plot hist, some data that I've generated up here in my crazy function, and just a title that I want. And here's a histogram. Wow, look at that. So it's very easy to kind of explore your data in a Python Jupyter notebook. And you can do R, and if you set up those crazy RPy2 or reticulate things, you might be able to get them both working at the same time. Let me go back to my slides. What else did I want to cover about Jupyter Notebook? Oh yeah, if you run Jupyter Notebook on a BI, on the BI servers, which you can do, make sure that you keep the key, which is printed out into your console. By default, it will try to open in your browser. If it doesn't, you might have to click one of these links. If someone else gets this link with that token, they can run the notebook with your permissions, which might not be great because then they could hack things using your account. So don't do that unless you really know what you're doing. There are definitely ways to share notebooks. You can share the notebook file itself safely, because then when they run it as themselves and they're not accessing it as you. And there is a thing called Jupyter Hub that we haven't installed here. Yes. And yes, Nate. So yeah, using the Jupyter Notebook is pretty simple. You can run things using the toolbar or with Shift-Enter. You can restart the kernel. There's a lot of shortcuts in Jupyter Notebook, and a really, I killed it. Try restarting now. If you do Control-Shift-F, it will actually let you search through all the things that you can do. So if you're like, how do I make a cell markdown? You can just type markdown and it'll say,
okay, what's up?
I just hit M.
So I have a chicken. It's
Say again?
an hour and 15 minutes to cook.
Oh, okay.
Okay.
Chicken.
Give or take. I wanna take
All
your
right.
roasted.
So that's the quick whirlwind
Okay.
tour of Jupyter Notebook. Does anybody have any questions about that?
Half hour
so
bake
far?
the chicken. Yes.
Well, there's actually a mixture of
Nate, you are
sauce,
talking about chickens.
garlic and stuff.
All right.
I like that talk. That was interesting.
Maybe Nate is getting some chickens. So things you can do. You can write notes to yourself or the people who are going to receive the notebook in Markdown. You can learn Python by doing simple math operations and experimenting. You can use functions. You can define them in one cell and then use them in later cells. I'm just going to skip through these slides really fast because we're already past 4:30. You can load data and plot it. So here's a thing that makes some sine and cosine calls and then puts a grid on and a legend. You can do all the matplotlib stuff pretty easily. And it's very easy to run it and then be like, oh, that's not what I wanted. I wanted the legend to actually be in a different location, and then run it again. And you can kind of rapidly prototype. The old world would have called this a read-eval print loop, but now notebooks are all the rage. And they're better because they actually kind of integrate all the graphics and things that you can work with. This is just a handy tip. If you have a really high resolution monitor, by default, the notebook will generate a graph that's really like postcard sized. And you can easily change the defaults in your notebook to do that. You can also experiment with Python libraries that you don't really know. One thing I want to call out is if you have anything in Python and you're using a library and you're not sure how it works, let me find my matplotlib thing where I'm like, plot.hist, what is this thing? If I'm going to insert a new cell and then say, what is plot.hist? If I type plot.hist question mark and hit enter, oops, sorry, shift enter, I can type, I will get a signature to pop up that explains, here's all the parameters that that function takes. And then below there, whoop, ignore, it will give the doc string for that function, which is if you like Googled for the documentation, that's what you would see. So you can really quickly get to your local Python documentation of any function. That's pretty handy. Let's see, what else did I want to cover? So you could explore a library that's new to you. Once your notebook is complete, you can save it as a IPyNB. There are checkpointing functions and stuff, but you can also export it to an HTML file that you can then attach to an email. That HTML file will contain all of the charts and stuff. People can just scroll down and read it kind of like a narrative of how you were developing it. You can also export to PDF and other things. You can export to the slides like what I'm doing now, kind of with revealed.js. And you can also save it as a .py script. When you do that, it will kind of take the notebook and reduce it to a text file that you can pass to Python directly. And there will be a little bit of extra comments and stuff in there from the notebook code, but that's a good place to start if you want to make this thing actually a rerunnable script. So using the tools from earlier, you could say, set up a conda, make a notebook, do some experimenting, and then turn it into a simple script, note down what packages it needs in a installer type README, and say, if you want to use the script, just do pip install these packages, and then here's my .python file. Does anybody have any questions so far? It's been kind of a whirlwind like usual. There's more stuff I can cover for those who want to stick around and have time. Otherwise, I want to let people get back to their day. I know the Zooming is very exhausting and it's been a long day. So any questions, anything?
Hey, can we get a Jupyter Hub?
Can we get Jupyter Hub? I don't know. We're gonna have to talk to David about that.
Yeah, I think it'd be cool.
Yeah,
it would be a thing.
It would definitely require some thinking about security and stuff, especially with how the study drives work and things. But Jupyter Hub, for those who missed my real quick skipping over of it earlier, is the way to kind of have a central server that everybody uses and has shared notebooks on, and you can kind of give different people access to different notebooks and stuff. Thanks, Laurel. Yeah, any other comments or questions? All right. Well, if you want to keep hearing me blather, I need to take a little drink of water, but I've got a few more things that I do want to cover. I wanted to give everybody a little idea of a possibly useful homework assignment to try out your Python skills, and then also talk a little bit about installing miniconda on the BI servers, and then using a Jupyter notebook there through a SSH tunnel, so you can actually experiment with data on the study drive, for example, which can be pretty useful. All right, so part two. I was gonna have everybody, we didn't really have time, but I was gonna have everybody build a little file looper in Python that went over your downloads files or whatever. The simplest thing you could do would be figure out how to loop over a directory and just print all the file names in it. You could do fancier things like copy the files to a specific folder. You could do an even fancier thing where you check to see if the file already exists where you're copying. You can make a plot of the file sizes. That might be interesting. You could extract the EXIF header information from JPEGs and show that, or do some other crazy thing. We didn't have time, but if you feel like exploring in free time, those are just some ideas of jumping off points for learning simple like Python directory looping stuff. I'm gonna cover real quick the installing miniconda on the BI servers. I did document this in the wiki, but what's the difference between using a personal conda versus the study-wide conda and set study that I was kind of talking about earlier? If you're looking to share the code and use it kind of across the study in perpetuity, then you definitely want a study-wide conda. You don't want a personal conda because that's gonna go away when you forget about it or leave. But if you're just doing some experimenting, a personal conda might be just the ticket, and it's relatively easy to set up. So I've documented this on the wiki. You just terminal to the login servers. You wget, which is a way to get files over the web, the URL to this weird shell script that does spooky install stuff. You say bash, run this shell script, which is gonna go do a whole bunch of stuff. It's gonna ask you, are you sure? And you have to say yes to the various open source licenses. You can choose a location. I prefer something like home directory apps, conda, and then the version of Python that is currently being installed. I don't know if you have any recommendations, Nate. It's easy to move and clean up, delete, whatever you want.
And what's the wiki page that has the, what's it called? The wiki page
If you
that
search for
has-
Python, you'll see it. It's using Python in studies, I think, is the full title, but Python redirects there. So just Python. Once you've got the conda installed locally, it for some reason doesn't always update itself correctly. So this line forces itself to update any conda internals. Now the problem is going to be if you activate an environment in that conda and you install Jupyter Notebook and you run it, it's going to launch, but it's going to try to connect to a browser, and then that's going to fail. And even if you copy and paste the link into your browser, that's going to fail because the link says localhost : 88 something something port. To get that to work, you have to create a secret tunnel between your machine and the BI machine where the notebook is running. To do that, because people are logging on via the login.kek.wiseman, and it's just shunting you onto some specific server, you might not know what server you're on. You can always type hostname if it's not already in your prompt where you are. If you're on a Mac or a Linux machine, you can just type an SSH command to tunnel things. This would be tunneling from port 8889 to 8889 on your local machine. Just as an example, if I go back to my terminal, you'll see that by default, it tries to claim this port, but if other people are running notebooks on ports, it will just keep incrementing that number. So you have to look in, find that number, and then put that into an SSH command. And then you have to include your username at whichever server you're on, blah, 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 blah. Once you run that, then when you access localhost port 8889 in this case, it's actually going to be tunneled through all the way to the Baldi or Carlo on the other end where the notebook server is listening. I didn't finish this part of the slides, but there's a way to do it with PuTTY. You go into the connections, and under the advanced SSH stuff, you can set up tunneling. If you just Google for SSH tunnel PuTTY, you should find the information you need. So once you've got that working, you've got your Jupyter Notebook running on your terminal or your PuTTY. You can then finally right-click the HTTP localhost : 8889 or whatever link with the token in it, and that should let you connect. So the reason that can be really useful is you can run stuff actually against the study drive. Like if you've got large files on the study drive that you don't want to copy locally for IRB reasons, you can do experimenting on them there. You're really just viewing sort of a tunnel into the BI servers. Any questions? Any comments? Everybody's really quiet because I talk a lot, sorry.
Sorry, Dan, just, I mean, I'm actually trying to install a miniconda right now, and it just takes a while, so.
Yeah,
This thing.
if you do try to install miniconda, or if you installed it on your machine and it didn't work, like Andrew, I'll get back to you. We can definitely help you with those kinds of bugs and stuff. In my experience, miniconda has been pretty solid. I haven't had that many issues with it, but the larger Anaconda installer does seem to do some weird stuff sometimes. Don't know what's up with that. Well, thanks everybody. I'm going to shut recording off, and then if anybody has any questions that they didn't want to talk about on the recording.
Thank you, Dan. This is cool.
Oh, Zoom is crashing. Stop recording. Yeah, thanks for coming, everybody. You
This
wish
is
to
cool.
stop.